Space, the final frontier. These are the voyages of the Starship Enterprise. Its 5-year mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
Jupiter, named after the Roman king of the gods, is the largest planet in our solar system. Jupiter has a total of 95 moons. Some of these aren't even named yet. Although we don't have time to talk about all of them, we'll take a look at some very interesting and fascinating ones. 4 of its largest moons were discovered by Galileo in 1610. Today, these are known as the Galilean moons. At this time, they were also spotted by a rival astronomer named Simon Marius. Although Marius may have been the first one who had spotted these moons, Galileo actually reported his findings initially, so he's credited in discovering the moons. Even though Galileo gets credit for discovering the moons, we still use the names that Simon Marius called these bodies: Io, Ganymede, Europa, and Callisto. Io is named after a Greek princess who was turned into a cow by Zeus. Io is the innermost Galilean moon. Tidal forces from Jupiter and Ganymede pull and squeeze Io, heating up its interior. Io vents its excess energy with sulfur and sulfur dioxide volcanoes. It actually has over 400 active volcanoes. If we look at this painting of the moon, all these little black dots are active volcanoes. And if we were passing by it in space, we'd be able to see that. And the white is actually a blanket of sulfur dioxide, and that can actually sublime on the surface of Io. It has a metallic core of iron and iron sulfide, and that's overlain with a mantle of partially molten crust. It virtually has no impact craters because of all its volcanic eruptions, so it keeps renewing its surface, so it has a very new surface because it's so volcanically active. Europa is named after a Phoenician princess who was abducted by Zeus as he disguised himself as a bull. Europa's smaller in size than Io, and it's a little smaller than our moon. It's the smoothest body in the solar system. It's covered with ice, and it has a lot of cracks and breaks if we look at this painting. And scientists believe that's from it freezing and thawing. So if we were to fly to the Arctic, we would see similar breaks like that from the surface thawing and freezing ridges and cracks. Tidal forces from Jupiter help keep Europa's interior warm. We look at this diagram of an internal view of what the moon looks like. Europa has an iron core, it has a rocky mantle, but it has this layer which scientists believe is a subsurface ocean. And water is brought upward from the moon's interior up to the surface, so it can keep renewing itself, and that's why Europa has a really smooth surface. It's thought that this moon could possibly sustain life in some form, and people are very excited to maybe one day visit it or be able to explore the possible ocean. Ganymede is the largest Galilean moon. It's named after a boy who was brought to Mount Olympus by Zeus. He went on to become the cupbearer of the gods. Ganymede is made primarily of rock and ice. And if we look at this painting of the moon, we can see dark spots or dark terrain and light spots. The dark terrain is actually older surface area with craters, and the light area is newer surface area. Ganymede is the only moon to have its own magnetic field, and its magnetic field is twice as strong as Mercury's, and it's actually bigger than Mercury. So if we think about it, if Ganymede didn't orbit Jupiter and it orbited the sun, it would probably most likely be a planet. Callisto is the second largest Galilean moon. It's named after a nymph from ancient Greek mythology who is the companion of Artemis. It's the most cratered body in our whole solar system. And if we look at this painting here, you can see all these light circular areas, and those are all craters in the moon. It's composed of about 60% rock and 40% ice. There's not been much new geologic activity in the moon, and many astronomers feel that its surface area has remained unchanged since its creation, so it could be billions of years old. Jupiter's magnetosphere is the largest object in our solar system. If we were able to view this from Earth, it would be about 2 to 3 times larger than the sun appears to us. Its magnetosphere is about 20,000 times more powerful than the Earth's magnetosphere. Here's a picture that just shows what the magnetosphere might look like if we were able to see it visually in space. It's important because the Galilean moons and Jupiter's moons are especially tied to the magnetosphere, and Io holds a special relationship with it. Io orbits in Jupiter's high-energy magnetosphere. If we look at this diagram here, we can look at its relationship with the magnetosphere. Charged particles in Jupiter's magnetosphere run into its Io's volcanic plumes and knock the ions out of the plumes into the magnetosphere. This forms the Io torus, and that will contain charged particles, and it's like a big donut that runs around Jupiter. Electrons in the field produce radio emission. Also, a high energy ion flux tube connecting Io's poles to Jupiter's north and south poles is also formed. So in a sense, Io acts like an electric generator, and it can develop 400,000 volts across itself and create an electric current of 3 million amps. The 3 innermost Galilean moons also exhibit orbital resonance. Here, this diagram represents that. Io orbits Jupiter in 1.77 days. Europa has twice that orbital period, and Ganymede orbits 4 times the orbital period of Io. Callisto orbits too far out and doesn't have any connection to these 3 innermost Galilean moons. Jupiter has 4 inner moons. They're irregular in shape and not large enough to be formed into smooth spheres. They're also tidally locked to Jupiter. Metis and Adrastea are the closest inner moons. They orbit Jupiter in 0.29 days. That's faster than Jupiter takes to orbit on its own axis. They were discovered in 1979 by Voyagers 1 and 2. Amalthea is the largest inner moon. It takes 0.5 days to orbit Jupiter. It was discovered in 1892 by Edward Emerson Barnard. It's the reddest object in our solar system, and it gives off more heat than is absorbed from the sun. The 4th moon is Thebe. It takes 0.68 Earth days to orbit Jupiter. It was discovered in 1979 by Voyager 2. Here's a picture of Voyager 1 and 2. They were identical spacecraft, and they were launched in the 70s. They passed by Jupiter and its moons around 1979 and 1980. They're still in flight in space, and I believe they're nearing interstellar space. This is a picture of the Juno spacecraft. Currently, it's still in orbit around Jupiter, documenting its atmosphere and the moons. And its plan when it loses contact with the spacecraft, NASA plans to hopefully launch it to burn up in the atmosphere of Jupiter. Jupiter is a fascinating planet in our solar system with diverse and unique moons. I'm excited to see what new discoveries these worlds might hold for the future.